today. Now, some of this is going to be a little bit of a rehash of stuff I've done before, but what I wanted to do was just expand on how to use some of the chemicals. So in this case, we're talking about, we always talk about using Fernox and the different types of Fernox. So this presentation is intended to show you just a bit more about how to do that, I guess. So we're going to start off just very briefly with, if I can get my mouse to work here. First off, why is it important? We're going to go over some general plumbing configurations, heat exchanger technology, so we'll show some water quality failures, a little bit about water chemistry, water treatment and preventative maintenance, and then water flow. So why do we care? Basically, inefficient heat transfer. I've read reports that say that even a 1/16 of an inch of scale on the inside of a heating system can result in like a 20% drop in the efficiency of the system in terms of transferring heat into the home. So that's one of the big things is efficiency. You're going to get excessive fuel consumption. Leaks is a big one. As the manufacturer, this is the one that we worry about the most. You will get damaged boilers and you're going to get complaints. The most common cause of pump failure on the new TRX FTVN units, anything with an ECM pump. We're seeing magnetite build up in the pumps as a significant cause of failure, better than half. So a couple of cutaways of just some modern heat exchangers. So on the left side here, you've got a water tube style. The hot gas comes in through the burner cone in the center there, blows out into the chamber across these tubes. And like a moth to a flame, the scale is going to stick to the hottest part of the chamber, which in this case is going to be the inside third, typically, of these water tubes. And when we do see these fail due to water quality, they're typically anywhere from a third to a halfway full of, could be calcium, could be lime, could be magnetite. Those are the three most common. In the fire tube one on the right, you've got the furnace at the top, which is you can see the tube sticking up through the bottom of the tube sheet there. And what we see there is typically a 1/4 inch of crud build up underneath where those tubes are, and it gets right in between them. And just like ice in a crack in the road, that scale builds up and eventually it pushes those tubes apart and separates them from the tube sheet, and then you get a catastrophic leak. So there's a couple of examples of what water quality failures are going to look like. If you look at the left-hand side there with the water coil, a couple of things you want to take note of is look at the color of that steel. You'll notice it's all sort of a dark brown, dark gray color. That's because the steel has actually physically been overheated from the scale. So when there's water touching the tubing, it's going to stay silvery and stainless colored. When it starts overheating, it starts to change color. And what you're seeing is a temper color there. So it's, you've all heard of tempering steel. Well, when you temper the steel inside the combustion chamber, it changes color. If there's water touching it, that can't happen. So if you see this kind of discoloration, it's a bad sign. And if you look really closely, you can see just like growth rings on a tree, you've got a sort of outer layer, or inner, I guess in this case, that's a little bit lighter with a bit more calcium in it and a little bit of magnetite. And then it almost looks like they refilled the system somewhere halfway through its life. And then you get a darker layer with a lot more magnetite in it. And then on the right-hand side is just a ton of magnetite, probably a little bit of calcium and lime in there, but mostly magnetite.
Dave, just to bring up a point, the last heat exchanger for the water tube, if you guys are on a job and you start to see older condensing boilers where they're starting to break down and that PVC that they're using off the top is starting to get discolored and you're seeing a lot of high temperature there, once again, I go back to the old, 30-degree split, but that's why, because that heat, that burner can't get rid of the heat and it's just migrating up to the venting and it's causing more temperature there and stress, and that's what's burning up the PVC. So we had a conversation today with a contractor where he said, yeah, all my older boilers, condensing boilers, I'm not going to put the name out there, are getting brown PVC after they get all that buildup. And that makes sense because what's happening is the flue gases just traveling right up. It's not able to absorb the heat. That's why it's so hot.
Yeah, and that's another good reason why when you do a startup, always write down that flue gas temperature and the boiler supply water temperature. If you go back a year from now and you're getting all the same numbers, you're probably in good shape. If one of those numbers is significantly different, that's a cause for concern. and you want to find out what changed. So how do you get this type of buildup in the heat exchanger? Well, that's going to come from improper pH. So pH is the potential hydrogen, or better known as acidity or alkalinity, depending on which side of the scale you're on, conductivity, hardness, and dissolved solids. So, so we're going to go through each of these one by one and just talk about what they mean and what kind of tests you do for them. And then if you find something, what do you do about it? Okay, so pH stands for hydrogen, and what causes acidity in water is H plus ions, which is it's a hydrogen atom that's lost one of its electrons, and that means that it's hungry to get that electron back, and where it likes to get it from is metals, because metals usually have spare electrons hanging around in their outer valences. And basically what happens is if your pH is too low, if you're going to accelerate corrosion, you're going to get more rust, you're going to get more debris in the system than you would otherwise. If the pH is too high, and it has to be quite high to really be a problem, you can actually get a different type of scale formation, or you can get something called caustic embrittlement. And one thing you're going to want to watch as you go through and buy these chemicals, a lot of times people use glycol that's on the market. If you look at the pH of most glycol that's for sale, it's outside of the recommended range for the boiler, meaning it's going to be too high a pH, indicating that it's too alkaline. So keep an eye on that when you go buy your glycols. It does make a bit of a difference, and but as a rule, a little bit higher pH is typically better than acidic. So some common food items, just to give you some idea of acidity. So neutral is going to be sort of, blood, milk, regular tap water. As we go to the caustic end, you can see you've got like drain cleaner, bleaches, oven cleaner, that kind of stuff, ammonia solutions. And as you go acidic, you go all the way down to like battery acid. If you were to actually look up Coca-Cola, it would be somewhere down here in the sort of acidic range around 3. Which is actually one of the reasons why it makes a really good rust remover, is because it does eat away rust. So sorry guys, I just realized I might have opened the wrong water quality presentation for tonight. No, this is the right one. All right, sorry guys. Okay, so excessively high water or very alkaline water, this is something you might see if you were to convert an old steam system over. The chemicals that were used in steam systems tend to be very high in alkalinity. And this would be a caustic embrittlement, which it's basically a different type of corrosion. So it's no better than regular rust corrosion, just shows up and looks a little different. So we're going to first talk about hardness. Hardness describes the calcium, lime, and magnesium salts that are dissolved in water. We call them salts, even though they are basically like table salt on the table is sodium chloride. If you get calcium carbonate, that's a type of salt. You can get magnesium carbonate. Those are the common ones. And what happens is, as water dissolves through the ground, it picks up these minerals from the rocks that it's dissolving on the way through. And if you don't do anything about it, basically it stays in the water. And unfortunately, when it sees heat, it's like a moth to a flame. These salts will come out of solution and start sticking to the inside of the boiler. And so that's what hardness describes. When you see the term hardness, it's only calcium and magnesium. It doesn't mean that there's not other stuff in the water that's bad, or there's other stuff that could cause scale, but calcium and magnesium is the only thing that a hardness test is going to test for. The way you typically test for this is just go to your local swimming pool store or local hardware store, get a thing of test strips. They'll probably cost about 20 cents per test strip. So usually you get like 50 of them for about 10 bucks, something like that. And all you do is you dip it in the water that you're going to fill the boiler with. You wait 20 seconds typically. it's going to change purple, blue, pink, depending on the test. And you compare that to a little scale that's on the side of your test kit, and that's going to give you a rough idea how hard your water is. So this is a picture of a TFT boiler that failed after about 6 months due to lime scaling. The reason the scale buildup on this boiler was so significant had to do with the fact that it turns out it was actually on an open system. Somebody had hooked this boiler up with a wood-fired boiler that was in an open system, so it was always consuming a fairly large amount of water. And this white ceramic-looking material or porcelain-looking material stuck to all the tubes. This is typical calcium lime hardness coming out of the water and sticking to the hottest part of the chamber, which is right where the tubes enter. And it's a bit hard to see in the photo, but you can sort of see it comes in layers. As those layers get thicker and thicker, they push on these tubes, and just like ice in a crack in the road, it gets in there and it just pushes the tubes apart and it cracks the tube sheet. In addition to providing a layer of insulation under the steel. So instead of the water directly contacting the steel, it's now laying on this 1/4 inch or 1/2 inch thick layer of calcium, which actually prevents the water from directly touching the steel and cooling it properly. Now, if you use a typical descaler, when you're talking about a citric acid solution or something like most common descalers that are on the market, it's going to remove this type of scale fairly well. And just to give you some idea, if you were to take all of this scale out of a gallon of water that's 10 grains hard, the total amount would equal about an aspirin tablet, so about 325 milligrams, give or take. As you can see, stuck to the bottom of this chamber is several hundred tablets worth of scale, and that's probably because this system went through several hundred gallons of water during the boiler's life. So we've talked about hardness. The next thing is total dissolved solids, and this gets a bit confusing. Your hardness is going to show up on a total dissolved solids test, but the other thing that shows up on total dissolved solids is everything else that's not water. So what that means is if you have dissolved calcium and lime, and let's just say you had 10 grains hard, that's about 170 parts per million of hardness. If you did a TDS or total dissolved solids test on that water, you'd see 170 something, which would tell you that there's something in the water. The TDS doesn't tell you what it is or whether it's good or bad. It just tells you that there's something there. And the rule when it comes to dissolved solids is if you know what it is and it's okay, so if it turns out that it's a scale inhibitor or it's a corrosion inhibitor, great, don't worry about it. If you don't know what it is, and in most heating systems you're not going to know when you show up, you kind of have to assume it's bad. And again, the other thing that you want to use this total dissolved solids for is if you were to test a water sample, and the water sample could actually be really catastrophically bad for the boiler, it might show 0 or very low hardness, but could be filled with a lot of this black debris, which is magnetite, which is equally damaging to the boiler, but you will not see it on a hardness test because magnetite is dissolved iron, whereas calcium and magnesium are the hardness. So a hardness test is sort of half of the information. It tells you what portion of the water is going to be hardness. Everything that's not hardness is typically something we would consider bad. Usually it's going to be dissolved iron, could be dissolved copper, aluminum, manganese, all sorts of stuff that gets into the water that would make it potentially unsuitable for the boiler. So again, follow what Ralph says. If you don't know what it is and you see a high dissolved solids number, stranger danger. If those dissolved solids are something you know, so if you know that you've just dosed a system with 300 ppm of Fernox, and you do a dissolved solids test and you find that you've got 350 parts per million total dissolved solids, you probably have nothing to worry about. If you go take some tap water and you show 0 hardness, but you've got 1200 parts per million of something dissolved solids, you should assume that those are bad and probably don't want to put it in the boiler. And the other thing is basically all the stuff I'm talking about doesn't make the water unsuitable for drinking or human consumption. Very hard water is actually great for your bones, your teeth. It's not so good for your skin, but it does help your bones and teeth quite a bit. Um, but again, doesn't mean it's appropriate to stick it in a boiler, because although your body can use those minerals, the boiler can't. Conductivity is just a way to measure dissolved solids. So a conductivity test basically runs an electric current through the water. It measures how much electricity passes, and then based on that, it can give you an approximate dissolved solids number. The reason conductivity tests aren't the gold standard is just because they don't tell you anything about the nature of what's in the water. And where they can sometimes fall down is there can be stuff dissolved in water that does not increase its conductivity. So conductivity is increased when something's dissolved and creates an ionic compound. So it's got a plus or a minus charge to it, which allows electricity to conduct more easily. So adding salt to water, for example, will dramatically increase the conductivity. Adding iron would increase your conductivity. However, certain types of bacteria and things like that may not be electrically conductive, and they won't show up on a conductivity test where they will show up on a dissolved solids test. Roughly speaking, conductivity can be converted to parts per million of dissolved solids, and the ratio is about 0.62, give or take. So if you do have a conductivity tester and you get 1,000, I believe this is microsiemens per centimeter, that would be roughly equal to 640 parts per million, give or take. Turbidity is something that I think when most people think about bad water and they hear the term bad water, they're expecting to open up a tap and see something that looks like the jar on the right. In most cases, the jar that's on the far left, where it looks like just clear, clean drinking water, that water could be 40 or 50 grains hard, and you'd never know it to look at it, might not even know it to taste it. The jar on the right is potentially could be water that's not too bad to use. So the looks of the water is not always a good indicator of whether it's acceptable to use or not. You really don't know what you're looking at until you start doing some of these tests. And last one, suspended solids. Suspended solids, this is something that if you look at the jar on the right here with the high turbidity, if you have a lot of suspended solids, you're generally going to see that. That's going to cause turbidity in the water. It's going to cause you to see what's wrong. And most of the time when turbidity is a problem, it's got nothing to do with the water that's filling the boiler. Turbidity is going to show up when you drain a little bit of water out of your boiler that's a year or 2 years old, and you notice that the color of the water has taken on a noticeable tinge. In a lot of cases, it'll be black, which isn't the greatest, but it's an awful lot worse if it comes out red or orange, which indicates you've got active rust going on. So the water we want in the system is, we want it to be clear, clean water, and you want to fill it with something that you would look at and say, sure, I would potentially drink that. So this is just an extreme example of somebody that forgot to flush the excessively dissolved solids that were in their system. Best I can tell here, somebody stuck the boiler on the wall after having shut the 2 valves to the old boiler and cut the pipes off, attached them to the new boiler, opened the valves back up, and all of the flakes of debris and magnetite and calcium and lime that were in the old system and got knocked loose from having drained and played with the system just flooded right into this boiler, plugged it up from top to bottom, and destroyed it within a matter of weeks or months. Now, obviously, all this stuff would quite happily be pulled out by a Y strainer. That being said, even in a system with a Y strainer, you'd probably only run it for about 12 seconds before it plugged up and you had to clean the Y strainer. But a strainer on its own will only remove larger particles and doesn't do anything for dissolved stuff that's in the system. So we're going to talk about that in a second.
And Dave, that picture was taken at the top of the heat exchanger, right?
It is, yeah.
So all that crap had to go from the return all the way up through the supply and lay up in there. That's amazing.
It amazes me that it happens like that too. So it was. We see probably one a year that's in that kind of condition that somebody wants warranty for it. So, Most of them aren't quite that bad, but we've got some doozies over the years. So all of the conditions we talked about are going to prevent effective heat transfer. You're going to get overheating and lockouts. You're going to lose efficiency. You are going to get sticking, burnt out valves. Everybody generally says that air vents are terrible and they all leak, which is largely true. They will all eventually leak. The thing to remember with all your air vents or your auto air bleeders is if they're all leaking, it's because the water sucks. If you have clean, clear water, your air vents will last a long, long time without leaking. The reason they leak is as they let a little bit of that dirty water out, the particulate matter gets stuck on the seat of the valve. And once you get dirt in there, the rubber can't seal up the dirt properly. And you get a little bit of seepage, which brings in more dirt. And then next thing you know, you get a dribbling air vent.
Well, Dave, and I want to add on there, you mentioned air vents, and now a couple times this week, I've had to address the fact that if you have a micro bubble air absorber on the system, all of your air vents, once the system's purged, should have the caps tightened down. Otherwise, the water will pull air into those, which is why Cliffy makes a check valve for coin air vent. I mean, for the air vents now.
Yep. And and it's a topic for another day, but if you size your pumps improperly or choose your piping sizes incorrectly, the likelihood you can suck air into a system is just as good as the likelihood of air getting back out. So it all comes together to, as a system to work together for the heating system. So yeah, you need the air vents to get the air out, but treated improperly, they let air back in.
But what I like is Steve said high velocity air elimination devices. He never said air scoop. I never heard air scoop come out of his mouth. He said high velocity. That's the
Actually,
most.
what I said was micro bubble air absorber.
Well, you know what I mean. It's high velocity. It's not no freaking air scoop where you need 18 inches linear run. That we need to get away from on high efficiency boilers. That's a problem. It is.
Installed correctly, air scoop works.
Yeah. So yeah, that's another thing, guys. I didn't talk about it, but directly anyways. So everything I'm talking about is debris or crap that's in the water that doesn't belong. If you have an oxygenated system, you might have filled it with the best water in the world, but if your system remains oxygenated, it won't stay the best water in the world for very long. And that's because oxygen, when it's mixed with water, likes to dissolve and damage other things, especially metals, which most of our systems are made out of some sort of metal. And that'll actually invite minerals and things that we don't want back into the water, which can then deposit out into the heat exchanger and destroy your boiler. So in terms of tests, pH test strips, again, go to your local hardware store. There's really no excuse not to do this when you go to a job site. Whoever sells the boiler, go to the kitchen sink, take 2 or 3 drops of water, stick it on the test strip. It takes 20 seconds to get a reading. You compare it to the color chart on the bottle that you bought. 50 strips will probably cost you about $12, so money shouldn't be a problem. The pH range that's acceptable to go into the boiler is between 6.5 and 8.5. 6.5 is obviously getting a bit towards the acidic side, and 8.5 is up on the alkaline side, but both fairly mild. If you see tap water that's got a high pH, so tap water that's like 7.5, 8.5 pH, it usually indicates that the tap water is very high in dissolved minerals, because minerals tend to buffer the acidity upwards or make it alkaline. You're generally not going to get water that's a pH of below 6.5 if it's well or city water, unless there's something contaminating that water. So right off the bat, 20 seconds after you get there, you can test the tap water and you'll know at least whether the pH is good. Conductivity, you can buy testers for this. Basically, the way they generally work is they've got 2 electric probes. They dip into the water, and then you get a reading that's going to be measured in, I think it's microsiemens per centimeter, so it's a measurement of conductivity. You can also buy TDS meters. So these are electronic meters. You stick it in the water. These do cost a little bit more, but if you're doing this as a profession, I would say it's worth the investment. You're not talking thousands of dollars. You're probably talking maybe a few $100s to get a decent test kit. The time it takes to read is fairly insignificant. Again, it only takes you a few minutes, and we're looking for 300 ppm or less of dissolved solid. So that's everything that we don't know what it is, 300 or less, or 7 grains per gallon of total hardness. So if you know what the hardness is, so if you've done your hardness test, which again, that one's very cheap, very quick to do, you just dip a test strip in. And let's say you get a reading of 7 grains per gallon. Each grain is roughly equivalent to 17 parts per million. So 7 times 17 is, anybody do the math for me on that? It's going to be 70, it's going to be about 200 and something. 119. So if you had 7 grains hard water, that would be 119 parts per million. If you then look at your dissolved solids count and you see that it's 1200, for example, that would be water that you'd want to consider not using, because even though the hardness isn't bad, the other 1000 parts per million that we don't know about is probably going to be damaging to that boiler. Once you've discovered that you have bad water, whether it's high in iron, chlorides, copper, whatever it is that it's got that we don't want, there's a couple of things you can do, and that's really the main goal for this presentation, is to discuss how to fix these things once you've determined that you have a problem. In a lot of cases, you're going to find that your pH is going to be right in the range that we want. Your dissolved solids hopefully are quite low. And if that's the case, so if you check your water and you've got a pH of 7, you've got a total dissolved solids of, let's say, 150 parts per million, low chlorides, low copper, low iron, that's water that's acceptable to use. I would always recommend adding a Fernox inhibitor, or any inhibitor for that matter. Fernox just happens to be the brand that we know the best because we've worked with them for a long time. But use your preferred inhibitor, and you could use that water right out of the tap. Once you've discovered that the water's not within the range that we allow, that's where you're going to have to start treating. So first thing you want to do is never assume. Everybody knows what assume means. It makes an ass out of you and me. It may look good, it may taste good. It doesn't mean that it's suitable for the boiler. Test your boiler feed water every time. At a bare minimum, I expect everybody in this presentation to go to their local hardware store or their pool supply store, spend $25, get 2 or 3 test strip kits. They've got like 30 to 50 test strips in each bottle, so it's only 20 cents per job. Test the water every time. If you do nothing but that, you're doing a lot more than the average guy. Scale and corrosion inhibitors. These things are the easiest thing in the world to use. All you do basically is you're going to get a bottle of the appropriate inhibitor, whether it's Sentinel or Fernox or 80. You're going to fill your system up. At some point, you're going to spray it into the system using an injector. If the system's open, when you start using it, you can just pour it in when you fill that boiler. Always flush the old system. So especially with old systems, make sure you run clean, clear water through those old radiators, through those old pipes, till you get clear, clean water back out the other side. Never reuse the old water. Reusing old water is how you get that really crusty heat exchanger I showed you that was filled with lots of particles. Make sure you have adequate air elimination. Again, if you have an oxygenated system, you could have perfect water, but it won't stay perfect for long. After a few months, you will start to get corrosion. If you have a system that, like the one that Steve showed us, where it was a floor mount cast iron boiler, it looked like the rest of that system was copper, and Steve, you can jump in and correct me if I'm wrong, but even though the rest of the system was copper, the problem with having an iron boiler in there for 20 years is that iron boiler will dissolve and leave magnetic debris throughout the entire house. When you disturb that system and cut out the old boiler and put a new one in and flush and refill, you're going to get some of that dirt out, but a lot of it is going to remain stuck to the inside of the pumps, to the inside of the pipes. And over the course of several weeks or months, a lot of that is going to come loose and potentially can stick to the new boiler. So that's why you want to use a magnetic separator, and that's why Steve's going back to check it. With magnetic separators, they're not a one and done. Once you've put them in, you'll have to check them a couple of times. If they're getting an appreciable amount of dirt, you keep cleaning them until you don't see very much dirt, at which point you can extend the service interval.
So, David, you say that, and the system has about 3,500 square feet of radiant heat in Weersbo packs. So it's the white, milky, semi-translucent packs, and
Okay.
the first 4 feet of almost every supply side is gray from the magnetite. So you know that you have a significant amount of magnetite in that system before I even took a water sample. And when I took a water sample, there was a significant amount. I've seen more, but it was a lot. And how much is settled down in the bottom of that boiler or is laying in all that pipe out there, which is why we want to use the cleaner, right?
That's why I'm
Exactly.
curious. When you take that magnet, I'm curious on taking some pictures and see how much is in there. That'll be a great freaking example of, you did it, you were there, you saw it. Now you took a mag, you went back a week later, you took the magnet out, and here's the pictures. That's just rock solid information.
I'm sure it will be added to the next Thursday with those slides
sure
I show.
I'm sure it will be. Recap, big side recap.
So yeah, any systems that contain a lot of iron or that used to contain a lot of iron, probably it's best to put a magnetic separator on. And the reason you want to do that is if you get magnetite scale build up inside your boiler, this is a really big problem because the descalers that we have available to us, which are mostly citric acid based, they basically will not touch magnetite. The magnetite, as a rule, comes from the heating system itself. It doesn't come from the feed water. So it comes from a heating system that's dissolving. And once you try and descale that out, if it's magnetite buildup, you're going to be unsuccessful because anything strong enough to take out the magnetite is also strong enough to eat holes in the boiler. So calcium and lime can be dissolved out. You should never have to do that, but at least if you do need to, it's possible to clean it once you get a magnetite problem and it's built up in the boiler. There's very little you can do to fix it. So I would say where practical, so I'd say it's always practical or always recommended that you fill the boiler with treated water to begin with. There's a couple of ways you can do that. One is to truck the water in. You can treat the water on site if there's a water softener available. If you don't have a water softener available, you can get water softeners in a bag. I think I've got a few slides showing those in a bit. And basically all they are is a resin bed that you pass water through, attached to a hose. You pass it through one of these resin beds, fill your system, and it softens it on demand. And of course, make sure to tell your homeowners if they get any system leaks, they need to be repaired ASAP. If they leave those leaks ongoing, you want to make it clear to the homeowner that any leak that's left unattended basically voids their warranty. You're going to destroy the pumps, you're going to destroy the heat exchangers. It would be like having an oil leak on the car and not repairing it. Similar type of idea, except in this case, the owner can always keep the engine topped up with oil. The system's going to top itself up automatically, but each time it does so, that new fresh water brings fresh minerals, which is fresh damage every single time that drip comes out. So test meters and kits are easily available. This is a Fernox test kit that you can go out and buy. This has a number of test strips, and this is what they call a titration kit. So on the right-hand side, you've got some chemicals. You follow the directions. Basically what you do is you put some water in the little vial there. You put a couple of drops of these various solutions in there. It'll turn pink or purple or blue or whatever it's going to do. Based on the color it turns, it tells you whether the water's good or bad. The test strips, at a minimum, everybody should be doing that. They're so cheap as to be almost free. So test strips, go to your local pool supply, order them from Fernox, order them from 80. Spend $20. It's well worth it. The rest of the titration kit is less important, but still worthwhile to have. I don't think there's too many people in here that wouldn't go to a mechanic or that would go to a mechanic if he didn't have a scan tool. A mechanic scan tool typically runs a few $1,000s. This will run you a few $100s, and this is your scan tool for the water that's going into the system. So again, test kits are readily available. Again, they cover all the basic parameters, so they cover typical hardness, typical pH. They also have a test strip that tells you whether you've got the appropriate amount of inhibitor in your system. And again, the way you use the inhibitor test strip is you dip it in the water, and you can see on the right here, it'll show you kind of a bluish color if there's none of it. If there's a significant amount, it's going to turn kind of a brownish color. That tells you that you've dosed the system an appropriate amount. With Fernox inhibitors or any inhibitor, you can undertreat and the system is not very effective. The nice thing is you cannot overtreat. So if you put in 5 bottles where 1 bottle was needed, it's not going to do any harm to the system. If anything, it just means that you've buffered up that system so that even if you do get a bit of leakage or water changes over the next 10 years, you still have excess Fernox to take care of it. So there's the Fernox T3 test kit, part number 63600. So if you have a Fernox rep, you could order that from them. Now, Fernox recognizes that not everybody wants to be a water quality expert. So they have these packages that you can buy. So basically what you're doing is you pre-order these, and what they're going to send you is a couple of bottles that are just empty. All you do is you fill those bottles with system and feed water. What you're paying for is the lab tests and everything in advance. They send you a prepaid label. Everything's sort of coded so that when you receive your serialized kit, when they get it back, they scan it using a little QR code that tells them, who bought the kit, who's getting the results, and they'll do a professional water quality test at their lab. These kits cost a little bit more, but the amount of information they give you is phenomenal. They'll give you probably 15 or 20 different chemicals. So they're going to do iron, manganese, silicon. They're going to do dissolved aluminum. And where these can be very useful, especially with an older system, is you'll notice it says fill and system water. So your fill water is what you're putting into the boilers to fill them up. The system water is what's in the system. Where that can be useful is your fill water might contain 0 aluminum, for example. But if you go back a year from now and your system water now contains, 50 or 100 parts per million aluminum, assuming that there's some aluminum component in your system, it means something in that system is dissolving into the water, and you may need to treat the water to prevent that corrosion. Thankfully, there's not much aluminum in systems these days, but one that you might see build up quite a bit is copper. We use a lot of copper in our systems. If you're getting a lot of copper in the water, it indicates the water's become corrosive to the copper, which obviously could create you a lot of headaches due to leaks, but again, it could also cause the system to plug up as well. So now that we've done a little bit of basic testing, you've determined that yes, your water is good, bad, or indifferent. What are you going to do to treat the system? And that's what we're going to talk about next. So what I would recommend, every time you or your salesperson sells a job, before they leave, so they've gone in, they found an iron boiler or an old condensing boiler, doesn't really matter, whatever it is. They found a boiler, they're going to replace it. They've scheduled a job, 10 days or up to about 2 weeks from the day they sold it. What they can do is go to a boiler drain. You can get F3 cleaner in an injection kit. So it's basically a spray bomb that you screw onto a boiler nozzle, or sorry, a boiler drain. You squeeze the trigger, it will inject the cleaner under pressure, and you leave the F3 in the system for anywhere from about 2 hours up to 2 weeks. And what that's going to do for you is the F3 is kind of a detergent. It will remove light scaling. So if you have a little bit of built up scale in the system, it will help to get rid of some of that. It's going to dissolve old fluxes. And the main thing that the F3 is good for is it grabs all those little particles of dirt that are in the system, and it keeps them suspended so that when you flush the system a few days later, they're more likely to flush back out again. So this is some research that was done by Fernox. So, and it just tells you gives you some idea what the effectiveness of these various chemicals are. So if you just power flush, so you just flush clean water through the system and do nothing else, the expectation is you're going to remove about 20% of that debris. If you do a power flush using an F3 or a DS40, you're going to remove, sorry, I shouldn't say a power flush. If you soak the system with F3 or DS40, so you introduce this into the system, let it circulate for a couple of days, and then you drain it and refill it, potentially you can remove 40 to 80% of the debris. And if you power flush with the cleaners, then you can get 60 to 99%. And again, those chemicals, it's just like everybody in here, I'm sure, has worked on an old cast iron boiler system. And Steve, I know you've done this. You get that black water on your hands, and when you go to rinse it off with plain water, does it come off?
Not only can you not get it out of your calluses, but the smell is like death, and you can't get that shit out of your clothes. And if you get it on the floor, you can't get it out of the concrete.
Yeah, so if you go to a system that's got black water, and we've always been taught that black water is good, well, all that black is magnetite, and the reason it's so difficult to get out is the particles are very, very tiny, probably on the order of about 1/10 of the thickness of a human hair. So very, very small particles. They get into little cracks, they stick, and so if you just flush a system and think, oh, I pushed clean water through it, I've got clean water coming out the other side, I must be done. There's a good chance you're only removing 20% of that debris. In order to get a little bit more, what do? You go home, you take some dish soap, you wash your hands, you get a bit more off. And then if you really want to get it all off, then probably what you're going to have to do is take out the nail brush and scrub the crap out of your hands with a lot of soap. And that's what these 3 levels of cleaning are: rinsing your hands off, F3 and DS40 is using a bit of soap, and then power flush is using the nail brush with some soap and water and scrubbing your hands to get all the dirt off. And you can imagine if it's that hard to get it off your hands, it's going to be that difficult to get out of the heating system. So keep that in mind.
Well, listen, I took out a lot of that black shit. Steve knows 9 buckets of it. So it's nasty. Let me tell you, it is nasty. When I put 4 bottles of F3 in it and let it run to 2 weeks, and it took a lot of crap out.
Yep, and that's the whole point of it is the F3 cleaner. It binds on to the dirt, so it likes to stick to the dirt. The chemists have done their homework, and they know that whether magnetite's positive or negative charge, that the cleaners will be the opposite charge, so opposites attract. It sticks onto those debris, and it makes them less likely to stick back to the system. That's how soap works on your hand. Soap doesn't necessarily remove debris particularly well, but what it does do is as you move that debris around, it stops it sticking again. That's kind of what Fernox does for your system.
Well,
So,
and the other thing is, I think it helped my heat transfer too across the board, because remember, I got all that shit out of the radiators, and now this place is running at 130 degrees. I turned it down to 130 degrees this
yep.
week. It's getting too hot because the heat transfer is better. I mean, you got all that crap out of there.
Yeah, it's a very small amount of, and if you want to know how little it takes, everybody's, I'm sure, stuck a bowl of soup or something in the microwave and you've overheated it. If you take even 1 or 2 layers of paper towel and stick it over your hand, you can probably take out that bowl that's scalding hot that you couldn't touch with your fingers.
Right.
If you get a layer of scale inside your heating system that's the equivalent of two or 3 pieces of paper towel, it's going to have about the same insulating characteristics. So you can see how much difference in heat transfer that makes just by touching with your hands. So a very thin layer will prevent a lot of heat from transferring.
The only good thing is when I used the magnetite and I got all the magnetite out, but I didn't have, knock on wood, I didn't have no leaks. That's the thing. When you start to remove all that sediment, all those years, now you have to worry about the other things that have come with the sediment that's in the system. And it's like,
yeah, and something like something like F3, I wouldn't be too concerned about putting that through an entire heating system.
yeah,
Where it would be a bit more concerned is using something like a DS40, which is a much more aggressive cleaner. As a rule, I would reserve DS40 for descaling plate exchangers and descaling boilers, but generally, unless I'm really confident in the integrity of the heating system, I wouldn't put it through a whole heating system if I could avoid it.
Last thing I'd put in the whole system is DS40.
Yeah, it's not hugely strong, but it is a lot of times really old systems they had some slight seepage over the years, and that seepage has plugged up any holes that might have been there. Once you start descaling them, you're descaling out stuff that fixed all those leaks. So something to watch out for if it's an older system. So
and I was worried. No problems with that. F30 did good, got it all out. I mean, Steve, you were here when I pulled the magnet. We fired the unit up. You know, everything was good. So it you have to treat it. But.
Yep. So to do a power flush, you can go buy the Fernox power flush kit. Really, all it is a pony pump with a pail built in. So you could do this with your own pony pump and a 5-gallon pail, or you can buy their flush kit, which I think is going to have a little bit higher pressure and probably a better flow than you might get from a small submersible pump. So you're going to want to make sure all of your zone valves are fully open. You're going to connect the power flush unit in series, so that can be done a couple of different ways. There's flange kits that you can buy that will allow you to pull out a pump and stick your power flush in place of the old pump, so that your pump is now pushing through the system. Sorry guys, just 1 sec.
Well, you know, you can also mention that we did Fernox just did a video at our training facility up there, so that shows this new power flush facility, the training process too.
Well, it's also important for everyone to know that this is a residential power flow machine. They also make commercial ones that are much bigger.
Yes.
And come on a big cart, and they got a big ass pump, like, you know, like a 3/4 horsepower centrifugal pump. So I mean, just know that, as David said, this is a glorified sump pump inside of a bucket that will do this. And it's a nice system for residential, but you're not going to go in and do a system with 3 and 4 inch pipe with this.
No.
Yep. Yeah, this is for your average residential home. You get into a big commercial job, you're going to want a bigger type of cleaner. So you're going to have a discharge hose that goes to a waste drain, which is just a floor drain or a laundry sink or something like that. If you got a lot of black stuff, make sure that laundry sink, make sure it doesn't look like it's going to matter if it gets a little bit stained, because some of that black stuff may not come out of the laundry sink. So don't ruin somebody's sink if you can avoid it.
It's a good point.
You're going to want to connect to fresh water to this. I'm bad for that kind of thing. I just, at home, I'm like, well, it's a sink. That's what it's made for. But obviously,
sometimes it can be a problem.
Yeah. You're going to use the power flush pump, and basically you're going to push water forwards and push it backwards through the system. When you descale a boiler, you want to push it forwards through the boiler, but you also want to push it backwards, because that reverse flow of water can dislodge debris that may not otherwise have come loose. You're going to gradually open, drain, and fill valves so you can introduce your cleaner, and basically you keep flushing back and forth as time goes on. Now, the other thing to remember, guys, if this is when you're power flushing an existing dirty system. If you're doing a new startup on a brand new construction home, you don't need to do a power flush.
Nope.
You should rinse the system. Basically, you're just going to fill it with water and drain it. But you don't have to do a power flush. You should definitely still flush brand new systems. And that's because there's a lot of flux and stuff like that, little bits of debris that get in there, little bits of Teflon tape, pipe dope. You want to get that stuff out so that it doesn't clog anything up.
Our flow meter.
Yeah. So when you're doing dynamic flushing, again, the water might be completely recirculated. You can also fully direct it to a drain, or you can do a bit of both. So what this is saying is you could actually introduce your cleaner to an existing heating system and let the existing heating system do the work. When I hooked up my heating system at home, I poured a couple of bottles of F3 cleaner in there. I filled the system, I bled the air, and I just let it circulate for the best part of a day before I drained it and refilled it. But I was just letting my existing circulators clean the system for me. And that in that particular instance, it's because it was a brand new system and I didn't have any concerns over dirt in the system. but I did want to get out all the old flux and solder residue. So I let it circulate for a bit, drained the system down a few times, and then refilled it with fresh, clean water. Now, if your system is really dirty, then that's when you want to do a power flush. And as I was saying, your salesperson, when they show up, sell the job, they should be putting a bottle of F3 in there. Let the old boiler take the hit. If you not dislodge a bunch of dirt, let it flow into that old boiler. And then when you take that old boiler out, you're taking the old crap with it.
Amen. You know, I tell the guys to say, listen, when the estimator gets that signed proposal, he's got that contract signed, they're going to do the boiler. Just give him that can with the self-injecting, walk down the boiler drain, show him how to do it, open up the boiler drain, put it on, open up the boiler drain, shoot it in, and walk away. 2 weeks,
Yep.
2 weeks, you're good. Within 2 weeks, you're done.
Yeah, up to 2 weeks. If you're going to be longer than 2 weeks, then don't.
Well, I don't know what their schedule's like.
May not be effective, but
some guys are. I heard guys are 6 weeks out right now. So
yeah, if you're going to be 6 weeks out, then don't leave it in there for 6 weeks. Yeah, you want to leave it for up to 2 weeks, not longer than that.
Some of these guys are 6 weeks out already. So I'm like, well,
so a lot of times you're going to flush water out of your system. It's going to look something like this. Basically, you want to keep pumping fresh, clean water in and getting rid of that crappy, dirty water until it looks more like this. At that point, your system's probably getting fairly clean. Now, for systems that are dirty, and there's two ways you can use this DS40 cleaner. This comes as a powder. It is basically citric acid. So if any of you guys have a Nespresso or a Keurig or Tassimo coffee maker, you know, every couple of months it asks you to descale it, and you go to the not to the hardware store, to the grocery store, and you get like the descaling solution. That's basically what DS40 is. It's crushed up orange peels, if you like. It's citric acid. The neat thing with DS40 is it's colored. So when you mix it up, it's quite a vibrant pink color. And as long as there's still DS40 active and descaling, it's going to remain pink. Once you've used up all of the chemical, it changes to kind of a yellowish clear color. And I've got some slides to show you this. Now, DS40 does tend to be a more aggressive cleaner, much more so than the F3. So, you never leave this in the system for more than 2 weeks. It potentially could, if you leave it in there long enough, it could actually start to eat holes and things that you didn't want holes in.
in fittings.
Yeah, I've had a couple of people over the years leave a descaler in the boiler for like 3 months, and usually everything starts to leak. So don't do that. You put it in, you're going to power flush this back out, or you're going to flush it back out. Leave it to circulate. If you can, leave it to circulate under temperature. Same with the F3. Leave it in there at temperature. This chemical is going to work a lot better. Like when you go to wash your hands, you're going to use hot water because it cleans better than cold water. Well, DS40 is the same. The chemical is more aggressive when it's hotter. So you mix this up, you pump it into your system. So you're going to grab a 5-gallon pail, put 1 or 2 cups of DS40 in that pail, stir it up, pump it into the system, pour it into the system. However you get it in there, let it circulate, preferably under temperature, for a minimum of about 2 hours and a maximum of about 2 weeks. Now, DS40 does have a warning on the label. If you have aluminum in your system, never more than 4 hours. This cleaner is quite aggressive towards aluminum. So all of the NTI boilers are stainless. You're not going to have a problem. But if you have other products out there, or if you have components in the system, I don't think there's anybody making aluminum pumps, but if you have aluminum in the system, use care with this stuff. 4 hours is the maximum. So that's a little jar that I mixed up at the factory. You can see it's kind of a pinkish red color. I was simulating scale by adding in calcium carbonate, better known as chalk. And you can see it gets all fizzy and starts releasing, in this case, it's CO2 gas, and dissolving. Eventually it turned milky once I'd used up all of the chemical. And after I let all the junk settle out, you can see it turned this yellow color. So where this is useful for you guys in the field, if you're descaling a plate exchanger on a boiler, for example, and I would consider descaling a plate exchanger or an indirect tank a routine maintenance. Mix up your 5 gallons, whatever it is, it's going to turn pink. starts circulating through the plate exchanger, if it keeps coming back, and keeps turning yellow, what's going to happen is that means you've used up all of the active ingredients in the DS40. So add another cup of cleaner in, and once that water starts returning back to you pink and it's no longer losing its color, you're done. When you're using white or clear vinegar, you're going to start descaling. You don't know when you've completed the job until, well, you really just don't know. You just circulate it through. You might have only gotten 50% of the scale, and there's no color change to indicate to you that anything's occurred. Whereas with the DS40, it'll start turning, this yellow clear color, and you keep adding a little bit more until it starts returning pink. And once it starts coming back pink, you're done. So that color change is a useful tool to tell you when you're finished descaling. So now we're going to talk a little bit about treatment of your system. So we've addressed the dirty system. We've either cleaned it and flushed it out, power flushed it, or we've rinsed out a brand new system. And there's a couple of things you're going to do here. So if you have or had, so the one that Steve just did, magnetite in the system, magnetite is just iron. So I've got a little chart for those that are interested in the chemistry here. So iron is just regular old iron. That's, we all know that, cast iron pots and pans, that kind of thing. And iron has three different oxidation states. So there's FeO, which is iron 2 oxide, which is going to be a black rusty material or reddish brown. Fe3O4, which is magnetite. Again, not the worst thing, but not the best either. And then the worst one you want to see is hematite. Hematite is red or orange rust that you see when you get a chip in the paint of your car, especially if you live in the Rust Belt. The problem with hematite, once you get to the hematite stage, there is no way to get that back out of the system. It's not magnetic, so it's not going to stick to a magnet for you. So a magnetic separator will do you no good. And again, anything that's strong enough to dissolve rust is probably strong enough to dissolve the rest of your system. So red rusty systems are really bad. If the system water is black, the good news is a magnet is probably going to be pretty effective at getting most of that junk out. So everybody knows this, especially if you live in the Rust Belt. That looks a bit like my first car. This is the red rust here is hematite. And then, of course, the black rust, which there isn't a lot of in this picture, is going to be magnetite. So here's just a little sample. It shows a little neodymium magnet right next to a jar of water that was filled with magnetite. And I know probably everybody in here that's been doing this for more than 10 minutes has come across a system with water like the stuff that you see in picture A. There's a real easy test for magnetite. When you go to an old system where you're doing a routine maintenance on a system, take a very small sample of water. 80 has these little magnets that are on, it's a magnet on a stick. You just dip it in the water. If the magnet comes out gray or black, you've got magnetite in the water. If it comes out, as white and clean as it went in, then your water's good. If you have magnetite, make sure you address it, because what happens is all of our pumps run on magnetism, and you might be seeing a trend here, but the magnetic powder that's in the water will be attracted to magnets. It's going to get attracted to the magnets that are in your pumps, and so if you don't provide a magnetic strainer, your pumps become that strainer for you and will self-destruct. Not to mention the fact that this will build up in the boiler and plug your boiler up. So there's a magnetic rod that's been pulled out of a magnetic separator. And again, you can see sort of three different levels of iron filings or magnetite that's been pulled out of that system. So that's why I say when you pull a magnet or put a magnetic filter in the system, it's not one and done. If you pull it out after 6 months and you've got the rod on the left, probably not too big a deal, but we've had jobs where people have pulled out the rod that's on the far right there after as little as 4 hours in the system.
Well, I'm hoping Steve pulls his out and his looks like that, and I'll be really happy then, because I'll know he's done a good job. If he pulls it out and it comes out like that, he's a rock star. You should say,
Yeah, if he sees the one on the left, he's got problems. But if he or it's the one on the right, I should say, he's got problems. If he sees the one on the left, that's probably more what I'm expecting from that system. But
well, I don't know. He
I
may have
guess,
loosened all the stuff he didn't think he had in there.
yeah, Steve, you'll have to let us know.
Yeah, we're curious now.
Um, Now, once you've put an acid in the system, which is what that DS40 is, you want to use a neutralizer. So Fernox has a bunch of neutralizers, and basically what these are is they're chemicals that are designed to interact with whatever acidity is left and destroy it and make your system neutral. So it'll bring it back to a pH of 7. If you buy a bottle of DS40, it does come with a couple of packets of neutralizer. And basically what you would do is you descale your system, and then you mix up the neutralizer, pump it through after the descaler to remove any remaining acidity. They also sell liquid neutralizers like this, and you can use whichever one you want. So now you've got a system that's been descaled, you've flushed it, you've cleaned it, you've put in your magnetic separators. How do you stop it getting bad in the first place? And that's where the F1 protector comes in. F1 protector it's kind of like wax, is the best way I could describe it to you. It tends to glom on to the inside of the system and sticks to the inner surfaces of metals. And it makes it so that it's kind of like Teflon coated or waxed, so that the dirt, it might still be there, but
Cholesterol
it can no longer stick.
Cholesterol pill.
Yeah. Um, so it's going to grab onto that dirt and make it less sticky so that it can't damage the system. It grabs onto the hardness. And again, the guys that know the chemistry know the positive and negative charges and the interactions with the chemicals. So they've created something that likes to stick to the dirt more than the dirt likes to stick to the boiler. So your typical concentration is 0.5 to 1% of the heating system. So roughly speaking, each 500 mils, and for you guys in the States, that's about a half a quart roughly. We'll treat about 25 gallons of water. You can buy this in a spray bottle format where it's got like a wand attachment or hose attachment on it that will inject into a pressurized system. You could also just, if you're putting in a new system, remove the relief valve. You've got a 3/4 inch hole there. Just pour a bottle of this in, put the relief valve back on. That's another way to dose your system. If you use a magnetic separator like the one Steve showed in his presentation there, those are designed to be feeder pots as well, so that you isolate that, drain it out, pour the cleaner in. You don't have to worry about doing any crazy mixing. You just pour this stuff in. It will mix with the system water after it circulates through the system for about a half hour. So a small amount of Fernox, so 0.5 to 1%, is good for maintenance, and that's the minimum acceptable 0.5% that you want to do for a maintenance charge. And what that's going to do is glom onto the hardness and prevent the corrosion. If you have a system that you're worried about and want to keep it a bit cleaner, or a system that you think might be a bit dirty, even though you've already flushed it, what you can do is double dose with your Fernox F1, and because you've double dosed, the amount of F1 in the system will actually glom on to some of those particles, making them slightly larger. And what that's going to allow you to do is use a side stream filter. And I've got a couple of slides later showing you how to use a side stream filter, but that lets you get very, very fine particulate matter out of the system so that you can help maintain an older system. So just to give you some idea of the effectiveness, this chart comes from Fernox. I would never recommend you use water that's as hard as what they show on this table here. But if you're looking at this, it's saying up to about 19 grains hard or 325 ppm. Fernox can be up to 100% effective. We recommend a maximum of 7 grains of hardness. So you can imagine if it'll treat up to 19 grains according to this graph, then if you're only putting 7 grain hard water in, it should be very, very effective. That's the little spray bottle I was talking about. So you take off the plastic wand, attach it to the can, and that lets you connect onto a boiler drain and inject it. If you double up the dosage, there's a darker blue line, and basically what it's indicating is that potentially, and again, I would never recommend you tempt fate, but potentially up to about 25 grains hard Fernox, they're saying if you double up the dose, will protect your system against hardness. And again, that is just hardness. I wouldn't tempt fate on that one. But it's quite an effective product. And that's, again, just calcium carbonate. You see at the bottom, it says hardness of water is CaCO3. That's calcium carbonate. If you have magnetite, if you have dissolved silicon, dissolved iron, the Fernox is not going to be as effective against those type of chemicals. If you're somebody that likes to use glycol, Alpha 11 is one of the very few glycols on the market that actually meets the boiler manufacturer's recommendations for pH. So it's been buffered to maintain a pH of about 8. It effectively is glycol with F1 protector mixed in with it. So you basically just use it as it comes out of the can. You mix it with a certain amount of water. And it does not contain phosphates, nitrates. It doesn't contain EDTA, which is sort of an acidic compound. So it's basically your antifreeze and system protector. It's sold by Fernox under their brand. If you're going to use glycol in a hydronic system, it's probably the best one on the market in terms of safety for water quality. A lot of the glycols that are out there don't actually meet our guidelines. The pH on them is far too high. They're pH of 10 or 11. They're almost designed for a cast iron system instead of a condensing boiler system. More on the protection side, you can use various side stream and flow through magnetic filters. A Y strainer is really only going to stop big debris from getting in there. Anything that's much smaller than a grain of sand is probably going to pass through a Y strainer, whereas actual filters like the magnetic filters or a side stream filter, that'll take out particulate matter that's very, very small, probably in the range of 20 or 30 microns.
Yeah,
Hey,
don't
Dave.
rely on the filter in our pump.
Yeah, no, exactly.
Don't rely on that one.
May I add on the magnetic filters that not all magnetic filters are created equal. You have to size them to the GPM. You can't put
Yes.
a 10 gallon a minute
Good point.
magnetic filter on a 40 gallon a minute system,
Good
or
point.
the magnetite just goes right on by the magnet. So please buy the right size magnet for the right
Amen.
flow of the job.
Good point, Uncle Stevie.
Well, I
No,
ate a
it's a
$3.99
great
earlier this
point.
year. I don't want to do it again.
It's a great point.
Yeah, everything we do in this industry is all these products are engineered to work in a certain range.
Well, look for instance, up in our training facility in New Bedford, we have the small magnet that Uncle Steve put in, and we have the XL, which is the bigger magnet that handles more volume of water. So that's what they need to look at. There's two different type of magnets that they can get, and we have them both up there in our training facility.
Yeah,
They make magnets from 3/4 inch,
All the way up.
the 24 inch flanged.
Yeah.
So
I mean, holy shit,
do
you can
this for a reason.
yeah. So side stream filters, guys, this is for removing very, very fine particulate matter. Again, generally speaking, I wouldn't be too fussy with these unless you've got an older system that's been known to have dirty water in the past. As you can see, the way this is piped in, most of the water is going to bypass this filter. And this is designed to filter only about 5 or 10% of the water every time it circulates through the system once. And there's a little throttling valve on there. And this is for getting rid of very fine stuff. So again, if you double dose with Fernox, so say you did end up using water that was a little bit harder than recommended, if you double dose with the Fernox and then put a side stream in, the Fernox will glom onto some of those hardness particles and make them big enough that a side stream can pull them out of the water. Again, I wouldn't tempt fate, but if you want to go to the top of the class when it comes to protection, side stream filters are very good for that because they can get out very, very fine material. And this slide is basically just demonstrating that no matter what you guys do, how hard you work at treating the water, none of it means anything if you don't address system leaks. So if you have a big leak in your system or even a very small leak, I did the math on this one day because I enjoy that kind of thing, mostly because I'm a tech geek. But if you had a dripping pipe and it's losing 1 drop every 2 seconds, 24 hours a day, we'll do a real quick informal poll here. You can put it in the chat. How many gallons of water does your boiler consume each year approximately? So Steve will check the results, put it in the chat there. But so again, 1 drip every 2 seconds. So it's drip, 1, 2, drip, 1, 2, drip. How much do you go through in a year? Take your guesses and put it in the chat.
And that gives you a chance to take a sip of juice.
Huh?
Take a sip of something.
Oh,
Water.
So you're
Or-
asking someone, you're asking everyone if they would please to figure if it's just 1 drip every 2 seconds, how much water are you going to go through a year? And David, so I'm just going to throw this out here. $29, you can buy a 1/2-inch inexpensive flow meter to put on your fill valve, on your fill line, so you can see how much water it's consuming. And so far, the max I've seen is 4,000 gallons a month. I was just talking to someone today who's going through 1,500 gallons into their heating system a month. Now, this isn't just a drip, obviously, but this is something to
No,
look
there's
at.
a leak somewhere.
So anyway, so far we got a couple answers coming in. We got 1,000 gallons a year. We got 3,000 gallons a year. Somebody said it's a family worth a year. I'm not sure what that means, but so far we got 1,000 gallons and 3,000
Well,
gallons.
that's miling. That's coming from miling.
yeah.
He's not giving you usage.
The answer, guys, is about 1,000 gallons. So that little harmless drip that you see on a radiator,
Wait
that
a minute. That means that my lake wins the Kubi doll.
He does.
yeah,
He wins
all
it.
right. So Steve will
Oh my
take care of your
God.
prize there, Milik. Yeah, so even a very small leak that might seem insignificant will put a significant amount of water through your system. So all of your, you can imagine, all of your piping is going to be completely voided of any chemicals you put in, and all your hard work is going to go down the drain. So one of the things I really like to do, if you can, is get rid of the water pressure reducing valve, get rid of the backflow preventer.
Have your own
Type
system.
in something like this. This is a glycol feeder or makeup water feeder. This makes sure that all the water that you put in the system, even if there is a small leak, is water that you know the quality of. And it'll allow you to pre-mix your Fernox. And if you're going to put just straight water in one of these and not glycol, make sure that you do use a Fernox inhibitor, because you're going to require a biocide in there to prevent algae and all that kind of stuff from building up in the water. But the nice thing with these is, if this one's a fairly large one, let's say it's 10 gallons, if you get a system leak and your system loses more than 10 gallons, you've got a leak that needs to be fixed. This is going to take care of that. If you get 2 or 3 gallons worth of air, it's going to pump up, fill the system with air. Nobody's going to complain. You're not going to get any error codes. And the water that you put back in is treated water that's of good quality. And it also means that you're not tied to the municipal system. So again, you save the backflow preventer, you save the water fill valve, and you're going to have just one of these. So in review, at every single job, test. Don't take it for granted. You're going to test it. You're going to use the treatment that's appropriate, and then you're going to maintain using strainers, filters, and when you go back at the end of a year or 2 years to do your annual combustion chamber maintenance, which I know everybody is doing religiously, you're going to take a tiny sample of system water and you're going to stick a test strip in there. You're going to make sure the Fernox level is appropriate. And if you really want to go the extra mile, you're going to do a bit more of a water test, and you're going to look for high levels of iron or copper or zinc or whatever's in the system. And that's going to tell you if you've got a problem, because if your system water is dissolving your heating system, that's not a good thing. But you don't know unless you check. So again, test, treat, maintain. And that's it for today.
Thanks for watching the video today. If you'd like to check out more videos, see the link below. Don't forget to like, share, and subscribe to our channel for all the future updates. And also check us out on Facebook, LinkedIn, and Instagram.